I want to welcome up Davi Souza. He is a student at the King Abdullah University of Science Technology. He is one of the bigger space botany nerds that I've had the pleasure of interacting with. And in fact, in February 2021, he was named Young Space Leader in Brazil by the Brazilian Space Agency. So with that, Davi, I will turn it over to you. And I hope you are staying awake as well. Sorry to keep you up late.
No, is everything okay over here? My time, at least I'm one hour earlier than Ben. But anyway, hi everyone. I'm Davi Souza. I am a greenhouse specialist and researcher, currently based at King Abdullah University of Science and Technology, KAUST, which is in Saudi Arabia. And today I'll be presenting to you a project that I have been working on along the years, which is called the Small Scale Experimental Greenhouses for Research on Plant Systems Integration. In this slide, you can see a brief summary of this presentation, but I would like also to take the opportunity to say thanks to Grant Farm for the invitation to be here giving this lecture, and also congratulations for the Grant Farm teams for organizing this very exciting conference with a lot of very insightful presentations. Well, the introduction of my presentation, I will be talking to you about some agri-food systems perspectives on sustainability and resiliency. We are already aware of the challenges associated to agriculture nowadays, both on the forecasts on global population increasing, but also the food demand and the CO2 emissions, the greenhouse gas emissions. As you can see in this graphic, some trends on the business, agriculture business, both on trends as usual, like how companies are dealing with agriculture as nowadays, and these trends if we start looking at sustainable means to do agriculture here on Earth. But what I want to bring in this presentation is that how we can use all of this knowledge that was presented in this bunch of presentations that has been conducted previously in this conference, like both on the private sector, both in academia with research, how we can put everything together and share the knowledge and look for synergies between the efforts that are being put both on research aiming at agriculture here on Earth and also in the future in space. And how we can do that. So I bring here just some features about the agri-tech sector. We are already aware of the current interests and investments in the sector, looking for controlled environment agriculture, greenhouse horticulture, vertical farming systems, indoor and urban agriculture. I bring here two examples. One is Red Sea Farms startup, which is the one that I'm contributing here in Saudi Arabia. Red Sea Farm is an AgTech startup aiming at scientific and technological developments on agriculture in the desert. And the second one is Aero Farms, which is a well-known company that recently came up with this research and development indoor vertical farming facility, which is a very exciting project that is running there in the Emirates. But in this project, the address topic here is to deal with the software and the hardware and how we can implement both of them into a methodology that can provide a better understanding on deep interconnection, impacts, and dependencies between the built environment, which is the system perspective, and the natural environment, which is the plant perspective. This is what I'm calling the plant system integration. And the main goal of this project is to promote a collaborative research to the continuous improvement of modern farming. How we can put all of the efforts from academia, from researchers, from companies, and put everything together with one big goal, to address a more sustainable agriculture on Earth and apply that in the future in space. So this project came up with a methodology that is started with some design requirements. These are the non-functional requirements, which I'm bringing to you. The first one is the research-oriented perspective. Basically, it's to bring a multidisciplinary scientific and technological advances contributing on system optimizations and integration of capabilities, and the focus in continuous improvement engineering. Then standardizing the systems, promoting benchmarks in CEA, put everything in a unified platform to allow the interpretation and comparisons of the data and access the generated knowledge, both on the greenhouse data and the greenhouse design. How we can make all of these features of greenhouse systems, how we can make them talk with each other. And finally, the reproducibility of this greenhouse, this experimental greenhouse, and put this into a practical testing environment aiming at AgTech applications to validate new solutions and systems and come up with some products and services for real scale greenhouses. The expected outcomes, first is the technological applicability, how we can make solutions available and affordable for the general public. Also to benchmark these facilities for indoor farming and CEA around the world, and come up also with some professional education, both to train new professionals into agricultural and technical and technological skills, and which we are listening a lot today, the space farming features, especially on research and development infrastructure. And this is what I'm calling the tech-enabled sustainable agriculture, putting together the technology and the sustainability aspect with one main goal. And for the applications of this methodology, I bring here just some examples for you. As you can see in these pictures, we have been doing a lot of efforts, the human beings putting a lot of efforts in space farming, which has started since the 90s with the first automated greenhouse that was sent to space, and other project that has been carried on since the years. And now we have the APH greenhouse, the APH system aboard the International Space Station, and we are started deploying some concepts for future missions on Mars. And this is a step-by-step process that started from the lab, from the laboratory, and came up with some improvements until the flight model. So this perspective come up with mission objectives, functional requirements, the prototyping and the testing of these systems. But how we can make all of these systems communicate, all of the data, the knowledge generated by these systems, communicate between each other? How can we integrate this and promote synergies between them to enhance these advances into a new this technological agriculture? I bring here another example that I have been able to put into my personal efforts. The first one is this experimental and research and development greenhouse developed for Pink Farms Company, which is a vertical and urban agriculture company in Brazil. This system has the main features on microclimate optimization and cultivation in two different hydroponic systems, hydroponic techniques, which is the NFT and the aeroponic. And the current project that I'm working on together with Red Sea Farms, aiming at these greenhouses, I had the opportunity to apply the same methodology to come up with this design with 26 sensors, one camera, and more than 30 parameters tracked in a real-time basis, with the focus, which has the focus on adaptive lighting systems, research for cultivation of leaf greens and food crops in a desert environment. And the main aspect here is to deal with food as an engineering problem, and how we can do that. First, we should turn data into insights on greenhouse design, cost estimates, environmental features, and yield. And this is a thing that is already being done by AgTech. Recently, they have launched the AgTech Designer, which is a software with capabilities to model farms and come up with some estimations to deploy an indoor farming installation. And now we are collaborating to add some space farming capabilities and space farming efforts into this platform. So we are expecting to come up with some good results in the near future to this software. And the second one is to promote a data-driven automated response for system control and operation based on constant monitoring. And I bring you an example of a project that is being developed by and a student at the University of North Dakota, Tarun, and also with me. And we came up with this concept called BRIDGES, which is Biological Reliable Integration and Design for Growth Environments in Space. And as you can see in these pictures, we started with this triangle, considering the main features associated to an atmosphere that is feasible to cultivate crops in space, which are the main capabilities and main features associated to this future controlled ecological life support systems. And with that, we were able to promote the synergies between the main cultivation systems, the illumination, the atmosphere management, the nutrient delivery, and the control unit, let's say like that, and how this communicates, how the communication is established between all of them. And finally, how we can add the human being in the loop, how we can add the human in the loop in this controlled and closed environment. This is a project that is still under development, and we are looking for future collaborations and perspective to come up with new results and come up with a small scale application of this concept. The final considerations of this presentation is that I bring to you just one idea on how we can use the technological solutions, all of the efforts that has been put into space farming and also in agriculture here on Earth, as a support tool to address sustainable development and climate change, how we can use this knowledge, put it into a space sector to address these sustainable development goals, how we can deal with that, how we can approach that in a better way, and finally, to build capacities for the next generations of farmers, not only here on Earth, but future in the near future in space. So thank you very much for your attention. These are my contacts. If you are interested to know more about this project, feel free to contact me by email or on LinkedIn. And I also thank you very much for the opportunity to be here, approaching my mission, which is positively impacting people's life with agriculture, space, technology, and innovation. Thank you.